Are not familiar with Drake Well Museum and Park, we are located in Titusville, Pennsylvania, and we are one of 24 historic sites owned by the Commonwealth of Pennsylvania and administered by the Pennsylvania Historical and Museum Commission. We are supported by our nonprofit group, the Friends of Drake Well Incorporated. Drake Well preserves and interprets the site of the Drake Well, chronicling the birth and development of the petroleum industry in Pennsylvania and its growth in the global enterprise. We are pleased to have us with us tonight, our speaker, Natalie. And Natalie, please, I might mess up your name, Pekney?
Very good.
Thank you for presenting and helping us shake off the winter blues. And we would like to also thank our partners, the Friends of Drake Well Incorporated, for helping bring us this program. One last time, let's go over a few little logistics before we get started. Just a reminder that we ask your cameras to remain off and your microphones muted. If you'd like to ask questions, we have the chat feature down at the bottom of the screen. At the end of the program, we'll answer your questions and maybe even call on you if we need further clarification of your questions. So please feel free to use that. And finally, I'd like to turn things over to our presenter, Natalie. And Natalie, if you could give a little introduction about yourself, that would be great.
Yes, thank you. While I'm doing that, I'm going to go ahead and share my screen. Oh, this is saying that you've disabled participant screen sharing, Sarah, so you might need to allow me to share.
Okay, you should be able to do that. Sorry.
Here we go. Okay. Move that out of the way. Okay. All right. Does that look okay on your screen? You're seeing my presentation now?
That looks great.
Good. All right. Well, thank you so much for having me. I'm really, I've been looking forward to this opportunity to present some research that we've done. And we actually were on the schedule to present this exact presentation back in March of 2020, right when the pandemic started. So unfortunately, that had to get canceled, and we're glad to finally get the opportunity to give the presentation, even if it's virtually. It's still a project that me and my co-authors are really pleased about and are excited to share with you. So my name is Natalie Pekney. I'm an environmental engineer. I got my Ph.D. from Carnegie Mellon University in Pittsburgh. And since graduating, I've been working at the National Energy Technology Laboratory. And I'll say some things about the lab in a minute. But my area of expertise is in air quality and greenhouse gas emissions. So at NETL, I have been leading a program for the past few years where we are looking at sources of greenhouse gas emissions in the natural gas value chain and trying to quantify those emissions and figure out how to mitigate them. But what I'm going to be talking about today is one of the projects that we've been working on, and that is regarding abandoned oil wells, actually abandoned oil and gas wells, but this particular study, it's mostly just oil wells. And we conducted a study in Oil Creek State Park, which is right where the Drake Well Museum kind of borders. I'm going to acknowledge my two co-authors, Jim Sams and Moombi Mundia Howe. The three of us have worked on this project, including quite a few others throughout the few years that we executed the program. So just to put things in a little bit of context before we start, I have these two photographs here. One you can see is a historic photo taken by John Mather, a photographer kind of famous in that era, of the Pioneer Run area in Oil Creek, what's now Oil Creek State Park, back in 1865. And you can see the proliferation of oil rigs up along the hillside there. This was the start of the oil boom in that era. And then on the right, you see a photograph of what Oil Creek State Park looks like today. It's this beautiful, wooded, pristine looking parkland However, the legacy of these oil and gas wells remains as an environmental issue that we have to consider today. So briefly, just a little bit about the National Energy Technology Laboratory, my employer. We're a Department of Energy, Applied Energy National Lab. Our mission is to develop innovative solutions to make energy for our country environmentally sustainable, abundant, affordable, and reliable. And we have locations in Pittsburgh, Pennsylvania, which is where I'm based, Morgantown, West Virginia, and Albany, Oregon. So before I really start talking about our project, I just wanted to touch on some definitions. And I know this is a little bit dry, but I'm talking about abandoned wells. However, you may have also heard them referred to as orphan wells or legacy wells. So what does that really mean? And what are the differences in this terminology? So according to the Oil and Gas Act for Pennsylvania, abandoned wells are defined essentially as any well that's not been used to produce or extract or inject anything in the previous year. And then also they define an orphan well too, which is kind of like an abandoned well that has no known owner. So even though these terms are clearly defined, I'm pretty much, for the purposes of this presentation, I'm just going to say abandoned well because that's kind of the generally used term for both abandoned and orphan wells. So when I'm talking about abandoned wells, I'm talking about either abandoned or orphan together. So why do we care about these abandoned wells? Well, they can cause several different hazards. These pictures at the bottom are kind of extreme examples. But as you can see, these are kind of an obvious environmental problem, right? But they can cause issues for human populations if they're allowing brine or oil or gas to get into people's homes or their water supplies. They can cause ecological hazards if those fluids are getting into streams or wetlands. There's issues if the well site it has unstable ground or open pits, that could be dangerous. If they're near active or abandoned coal mines, which is, especially an issue in Pennsylvania, right? If they're near buildings or streams, there could be concerns with their impacts to those, as well as their emissions. They can be emitting gaseous hydrogen sulfide or methane into the atmosphere. And another hazard is that they can present a problem for any current or future subsurface development. So if any oil or gas well is being drilled in the vicinity, maybe like a Marcellus shale well, for instance, where you're doing vertical and horizontal drilling and hydraulic fracturing, if there are unknown abandoned wells in the area, that can cause some problems within the subsurface. And so nowadays, at least in Pennsylvania, there are regulations about how land developers and oil and gas drillers have to identify and properly mitigate abandoned wells within a buffer of any new development going in. Let me see if I can move this here. Sorry, I've got my picture of myself blocking some of the screen here, so I can't see the words. Okay, there we go. So nowadays, when a well is no longer economically producing oil or gas, we're required to put the well through a process called plugging and abandonment, or P&A. Which basically a drill rig a workover rig is moved onto the site, cement is pumped into the well, it covers the oil and gas production zones. Then on the surface, the wellhead could be removed, flow lines removed, etc., to try to restore the site to, kind of as close to its previous status as possible. However, these requirements weren't in place until the 1950s. And you might know that the Drake well was drilled in 1859, which kicked off an oil boom in that area and then kind of across the country in different oil and gas producing states. And so there are hundreds of thousands of wells that were drilled before the 1950s that weren't required to be plugged or abandoned. And as you can imagine, and I think this photo kind of might give you a little bit of a feel for that, but documentation back in those days was probably not great, right? So record keeping of every well that was drilled and exact locations, we do not have that information. Certainly there were no high precision GPS back in the day for recording really accurate coordinates for a well's location. And even documentation about how much a well would produce, when it was abandoned. In many cases, we don't have that information. We might not have any information at all about a well that was drilled. So a big challenge for us to figure out how to mitigate this environmental problem, how to go in and actually plug these wells. It's just how and where can we find them, knowing that the documentation that exists is incomplete and sometimes inaccurate. So everything that I'm presenting today is actually, you can find it online. I just wanted to point this out, that we have summarized our entire project in something called a story map, which is like a user interactive way to view our results, some of which is kind of like in a map form. And you can click on different words for definitions. You can click on points to pull up more information or photos. And this story map can be found on the NETL webpage. I have listed a link here, but you can just find it if you Google NETL and Oil Creek State Park, and it'll come up right away. But when you do, then you can just scroll through it and navigate at your leisure. So if you are interested in something I say today, or you want more information, or just want to review, you can always take a look at our story map. So first I'm going to talk about how we prepared for this study of the abandoned wells in Oil Creek State Park. What we do is we try to mine any existing records that we can find, and then we combine that with some more high-tech techniques like aerial surveying. So the GIS data and records mining that we do might include digging up things like historic maps, like property and tax maps. We look at old photographs, which we're fortunate for this era and this location. John Mather was a photographer that really documented by his photographs a lot of the oil boom. We can look at state reports, aerial photographs. The US Geological Survey has maps from the early 1900s that we can look at. And then we also look at whatever digital data the state has. And in this case, where they have location coordinates for any locations of wells within Oil Creek State Park. And then having mined all of those resources, we also can use airborne data collection. So we can survey the park with various instruments that allow us to further locate the wells. So one thing that we found right away is when we're mining all of those data resources was that the Pennsylvania Department of Environmental Protection, the DEP, they maintain a database of abandoned and orphan wells. And according to their records, there are 767 wells within Oil Creek State Park. However, the Pennsylvania Geological Survey also maintains a database of well records, and it's called the Exploration and Development Well Information Network, or EDWIN. And according to the EDWIN database, there are 955 active and abandoned oil and gas wells within the park boundaries. So right away, you can see there's some discrepancies between these two databases. And then if you look at the map, the yellow line shows the border of Oil Creek State Park. So this is zoomed in on a portion of the park. You know, the red dots are the PADEP database locations, and the green dots are from the EDWIN database. Right away, you can see that there are quite a few instances where these dots don't line up. There are places where we have a well in one database that doesn't exist in another. There might be double accounting of wells where the locations are a little bit different in each of the databases. So clearly some discrepancies here. So what we then do is look to these aerial techniques for another way of collecting information about well locations. So what we found at NETL over years of research in various locations is that you can locate abandoned oil and gas wells using a magnetic survey. Wells are generally cased in steel, and the magnetic signature or the magnetic signal of the steel is different than the soil or the ground around it. So if you put magnetometers on an aircraft, like the helicopter shown in the picture there, and you fly over an area in a grid pattern and you collect magnetic signals for each point in that grid pattern, you can basically map out magnetic signals. And that's what the middle photograph or middle graphic shows, is the result of this aerial survey with the magnetometers on the helicopter. And so the kind of bumps, we call this a bump map because those magnetic anomalies look like a strong change in signal, so a bump. Those indicate the likely presence of a well, or at least the presence of some metallic structure that has a similar orientation as a well. And the picture on the far right then is just a zoomed in image of an area that was surveyed there. And you can see that we put a little dot, in this case yellow, of the highest, where the highest magnetic intensity was recorded, and we call that the coordinates where, a likely well location. So we figure out what those coordinates are, and then we can go out in the field and determine if we can actually find a well at those coordinates. So for the field navigation piece, we take various tools with us. We put that magnetic contour map on a field computer. You can see the field computer in the picture there and the zoomed in image of the map on the right there. So rather than having the color gradations, this just has purple contour lines. But we navigate to all those yellow dots where we figure it's a likely location for a well, and we get as close as we can to those coordinates, and then we look around and try to see if we could find the well. Sometimes there's very obvious evidence, a wellhead, a pump jack, easily visible. Other times it's a little harder to find. You can see the well in the photograph there. It's rusty, the colors kind of blend in with the woods around it. That one's, might have taken a little longer to find. So you can imagine that it's really important to get those coordinates pretty accurate. Otherwise, you could be very close to the well and have a hard time finding it. Also in the picture there, you see on kind of like a backpack harness, that is our GPS. And it's a lot more sophisticated than the one in your phone. This one gives us really high precision so that it helps us get as close as we can to where the well actually is. Oops, not too far. Sorry, there's a little bit of a delay with my computer. Okay. So in one of the objectives of our study was, after we flew this magnetic survey, we wanted to compare the locations that we got from the airborne magnetic data to the digital database locations that we had. In this case, we were looking at the Edwin database. And we found that if you compare the two locations for a well, we looked at each well that we found in the magnetic survey and looked within a 50-meter radius of that magnetic site. And we kind of used that as an attempt to reasonably match a magnetic site with an Edwin database well site. So we found that it's generally plus or minus about 25 meters. So there was some difference between the magnetic surveys that we flew and the database location. And you might think 24 meters being that far off is not that big of a deal. But again, as I said before, when the wells you're trying to find are very difficult to see, that's a lot of ground to cover. So in the picture, one of them is very clearly obvious. There's even a old wooden tank behind the well there, but the other two, one with casing that's cut off really close to the ground, and the other one that's just a little hole in the ground. Those are really difficult to find if you're not right on top of the well. So in the story map, if you go to the story map, it has a neat feature where that bar in the middle is dividing the magnetic survey results on the left and the database locations on the right. And you can kind of slide that bar back and forth and just compare. Okay, I see a really strong yellow bump right here. Does it correspond to a database location or not? And if so, how far apart are they? Another focus of the study was to identify undocumented wells. So as I said before, we already know that documented records, they're just not complete. There's probably wells out there for which we have no documentation. So we looked at the difference in the airborne magnetic data and the density of wells in an area from the database. So we looked at potential well sites that were far removed from the documented well sites. So we put together this well density map. We aggregated all of the Edwin database locations into 100 meter by 100 meter square cells. So those are those little boxes you see. And then the regions of the map that don't have any squares, those indicate that those cells do not contain any documented wells. So therefore, the potential sites in those empty cells, they might represent undocumented abandoned wells. And based on our analysis, there were a total of 588 sites that met this criteria. So let me see, I think well, I'll just wrap up the lessons learned, I should say, from our magnetic surveying of Oil Creek State Park. So we were able to find all of these undocumented wells, plus we were able to get improved locations for documented wells. And, you know, we're finding significant differences in the locations that are recorded, and the average was about, as I said, 25 meters. We also found that it's really important to have a high precision GPS. The one we used had like 1 to 2 meter accuracy. You really need that in areas where the well density is high, or wells could be difficult to find if they've, you know, had the casing removed or cut off near the ground. The helicopter survey that we did with the magnetometers, it was very effective, but in areas like in Oil Creek State Park and early development, when well density is really high, people were just drilling wells all over the place, and they're really close together. That makes it a little tougher. The resolution is not quite as good, but that can be improved by increasing the spacing of the grid that you fly with a helicopter, or you could do a walking magnetometer survey to improve that accuracy. And I will point out that nowadays we can do these magnetic surveys using drones. The magnetometers that we used back in 2014 when we flew the helicopter-based survey, they've been miniaturized. You can put them on a drone, and that allows us to do the surveys a lot cheaper. It's also, you can usually fly closer to the ground, so that gives you a little better sensitivity, but you can't cover as much area. So the helicopter, you know, can fly a bigger region. So there's a little trade-off there, but the magnetic surveys that we've been doing lately have mostly all been drone-based. Okay, so now I'm going to talk a little bit about a different surveying technique, and that's using light detection and ranging, or LiDAR. A magnetic survey, obviously, it has to rely on the well having an intact metallic casing. So that tool is not effective for finding wells that, excuse me, may have been constructed with wooden casing, which is the case sometimes for really early wells, or if the casing's been removed. So if there are those instances and the ground has been relatively undisturbed since, there's a good chance we can still see the footprint of where the well used to be using LiDAR. LiDAR is a remote sensing technique, so it's measuring the distance between a sensor and a target surface on the ground. So if you fly a survey similar to the magnetic survey, but with LiDAR sensors instead, you're measuring a distance to the ground at each point, and then you end up mapping out the ground surface. So we used this technique to locate potential abandoned wells, and we focused on an area in Oil Creek State Park around Pioneer Run. And there's two kind of interesting photos here from John Mather that show you in 1865 what it looked like, wells all over the place. And then 30 years later, the photo at the right, it's kind of like a ghost town. You know, the boom's over, everybody moved on. So rapidly changing landscape from, you know, just a visual like this, but using LiDAR, we can still investigate and find wells, evidence of wells that were drilled 150 years ago. So this map just shows you where within Oil Creek State Park, which is the green shaded area, that smaller red outlined area is the Pioneer Run area that we surveyed. And we did this survey with a drone. The LiDAR sensor was mounted on a drone. So this very small section of the survey that was flown, it's a zoomed in area. It's showing the ground surface. And what I'm showing you there are ground features that are indicative of wells. And the way we know this, you can kind of infer that based on the photograph on the right. You can see how typical well construction involved an engine house on one side of a rectangular well pad and the oil well on the other end. So what you see in the land is a rectangular kind of shaped bench formed with a pit or a hole on one side. So looking at the ground features, you can see footprints of what looks like those were locations of wells that you can still see on the ground. So from the LiDAR data, we were able to identify 78 sites as potential abandoned wells. And then we went out and field verified as best we could in 2019. And we cataloged 16 out of the 78 sites. And unfortunately, we were interrupted by the pandemic, so we didn't ever get to all of those 78 sites. But we found that at least half of the ones that we visited were likely to be abandoned wells. Unfortunately, due to the sometimes dangerous nature of the features, we couldn't really get in there and excavate the depressions to confirm if it was a well or not. Sometimes it looked like unstable ground. So rather than putting anyone at risk, we would just say, okay, this is a potential well site, but we're not going to excavate any further to confirm. So the high resolution LiDAR surveys that we did enabled us to correlate features from historic photographs like John Mather's photograph here to actual physical locations in the present. For example, you can see a colleague of mine, Garrett Velosky, who's since retired. He's holding a blown up picture of a John Mather photograph. Using the LiDAR, we could pinpoint the locations of those surface features and identify the exact location where that building in the photograph is, and one of the oil wells, or the actual well pad where one of the wells was. So it's just an interesting thing that we're able to do, linking this high-tech LiDAR data that we're looking at to these historic photos. So wood-cased wells, which we can't detect with the aeromagnetic survey, we found that they might be visible. We might be able to detect them with LiDAR. But LiDAR can only identify wells that have that distinct topographical anomaly. So there's limitations to both the LiDAR technique and the magnetic surveying technique, but altogether these two techniques really complement each other, and they have the potential to help us identify many abandoned wells, which we can then go out and verify in the field. Okay, now I'm going to shift gears a little bit and talk about gaseous emissions from these abandoned wells, which is something that I was interested in. I'd had colleagues working on well locating using the magnetic surveys and talking about instances where they could see visible evidence of a well leaking. Maybe if there was liquid in it, they could see bubbling, or they could smell a really strong hydrocarbon smell. So we started thinking about the fact that these wells that are unplugged have the potential to just be leaking methane into the atmosphere. Methane is a potent greenhouse gas. So what does this mean in the context of greenhouse gas emissions and potential for impacting, climate change? So the gaseous emissions from abandoned wells, back in 2014, when we did the aerial magnetic survey, was totally unknown and unstudied. So since then, there have been several groups, including those of us at NETL, that have collected some data from abandoned wells. So we, we know a little bit more today, but still a lot of research going on actively in this area. So the methodology that we use to detect emissions, we tried several different approaches. We've used laser-based sensors, we've used optical gas imaging, essentially infrared cameras. We use something called high flow samplers. And then we also collect samples of the gas from the wells to analyze the composition. So I'll kind of show you some pictures and talk a little bit about each of those. With a laser-based sensor, you can see some pictures of me and my team members pointing a little sensor at a well. Essentially, it's bouncing a laser from the detector to the well and back, or to a reflective surface and back, and it's measuring the concentration of methane in the column of air between the sensor and whatever it's pointing at. And so this is not giving us an emission rate from the well, it's more of a qualitative check for us to determine if a well is leaking or not. We also used another qualitative check, optical gas imaging. So we have an infrared camera. You can see on the left a photograph of a colleague using the camera to look at a well, and it pulls up the infrared of what the well looks like, and you can see a picture of that on the right. And the insert there, the black and white, is I'll try to play that video. There we go. So this is just a high sensitivity way of looking at the infrared imaging, and you could see in the infrared photo this circular hole coming out of the side of the well. You can clearly see in that black and white video, it looks like smoke coming out. So that's what we see when we look at leaking wells. It's essentially kind of looking like smoke that you can see with the infrared, but obviously you can't see it with the naked eye. So this helps us, it gives us some indication of if a well is leaking, what point is the well leaking from? If the well has a wellhead, there could be various potential leak points. So the infrared camera allows us to narrow in on exactly where the leak is coming from. What we really rely on to get a methane flow rate measurement is this high flow sampler. It's a backpack mounted sensor that's field portable. We can carry it around, and it has a hose that's pulling in a large volume of air, and it's sending a slipstream of that air into a methane sensor that works by either thermal conductivity or catalytic oxidation, depending on the concentration of methane. And it gives us the actual flow rate of methane from whatever source we're measuring. So this is the instrument that we really relied upon to get the emission rate of methane from these abandoned wells, and it worked very well. It has different attachments that you can either stick directly into the well, or it has various like a plunger looking attachment, or different configurations, so that depending on how, what remained of the well, what part of the wellhead remained, we could collect samples from it in different ways. And as I said earlier, we could collect gaseous samples from the wells and take those back to the lab and analyze the composition. And this helped us determine how much of the gas coming out of the well was methane. So this overall shows the results. And this exact information is shown on the story map if you wanted to dig a little deeper. But of the 137 wells that we visited and collected methane emissions measurements from, let's see, 67 of those wells were not plugged. So as I said before, plugging regulations weren't in place till the 1950s, and these are very early wells, so they had never been plugged. 71 of the wells, however, had been plugged. So at some point, presumably the state came in and plugged some of the wells, and it was really obvious when they're plugged, they're filled with cement, and they generally would have a PVC pipe marker sticking out of them. So as you would expect, and what we found, none of the plugged wells was leaking, which is great. Just as an aside, some of the studies that we've done in other regions, we have found plugged wells that do leak if the well wasn't plugged properly, or if the cement may be degraded over time, there is potential for the well to leak. But in Oil Creek State Park, we did not find any leaking from plugged wells. The unplugged wells that we looked at, 10 of them were leaking. So, and then in the graph at the bottom there, those orange bars show you the leak rates for those 10 wells. So one of them was pretty high, and the other ones were all kind of similar leakage rate. And this is indicative of what we see a lot of times, where A small number of the wells might leak a lot, but most of them leak hardly at all or just a little bit. So it's challenging for us to say, okay, well, here's the average leak rate when there's really high variability. So in Oil Creek State Park, of those 10 wells that were leaking, the average leakage rate was 0.29 kilograms per day. But then when you average in all of the plugged wells that were not leaking, of course, the average emission rate for all of the abandoned wells in Oil Creek State Park was actually pretty low. So what we do with this information is we want to try to understand a little better how much oil wells or abandoned oil and gas wells could potentially leak. We want to put them in an emissions inventory and look across regions. How does the emission rate vary? Are there parameters about the wells that help us determine whether or not it's more likely to leak? Does it have to do with the age of the well, geographic region? Clearly, we see plugging status has a big impact, right? Where usually a plugged well does not leak. So this helps us determine, kind of put the problem in context for the whole country, knowing that there are millions of wells across the United States. And, how big does this problem then end up being? And how do we focus our efforts to plug wells? So the map here of the US just gives you an idea of the distribution of oil and gas wells across the country. And certainly here in Pennsylvania, we have a long history of oil and gas development, a lot of abandoned wells. So this is an issue that's certainly of high interest for Pennsylvania. Oops. So something that we started at NETL hasn't really gained a lot of traction yet, but we're trying to engage citizen science, knowing that wells are sometimes difficult to find. Certainly there are a lot of cases of undocumented wells out there. So we have a website, we're calling it the Orphan Well Location Survey, where citizens can just go into this website. If you know of the location of abandoned well, maybe there's one on your property, maybe you encounter one at a park or something like that, you can go on the website, take a picture of the well, record its coordinates using the GPS on your phone. And just a couple other questions in there, like, is this well on your property and can we contact you? And then, it's an opportunity for us to investigate at some point and see if this is a undocumented well that we want to either measure the emissions from, get better coordinates for, update the database location, etc. And a couple things I'll leave you with. This is our standard disclaimer, because we're a national lab. Any of the instruments that I spoke about, I'm not directly endorsing them. And that we want to thank our site support contractor, Leidos, and the other team members that worked on the project, as well as the Oak Ridge Institute for Science and Education that funds our graduate students and postdocs that work with us. And lastly, here's some contact information for us at NETL, our webpage, netl.doe.gov. As I said before, if you look for the webpage and Google Oil Creek State Park, you can find our story map and get more information. And there's also my contact information there too. So I'm always happy to talk about the research that we've done and think about ways to investigate this problem from other angles. So I always enjoy talking with people about new opportunities. So that wraps up my presentation. I hope you enjoyed it, and I'd certainly be happy to take questions from anyone.
Thank you so much, Natalie, for your presentation. I think I'm going to ask the first question. You said that you were working in that area of Oil Creek State Park, Pine Run, but the pandemic stopped you from continuing on. Are there plans to come back to Oil Creek State Park at any time and continue the project on?
We do want to go back and there are some more sites that we wanted to verify. Some of in the LiDAR survey, some well locations that we wanted to just check and see if we could verify if there was indeed a well in that spot or not. The problem with the pandemic holding up our field work is that this isn't the only field project that we have. We've got quite a backlog now. So
right.
we'll get to it at some point, but we're just kind of slowly getting back into things. And actually I'm leaving on Sunday for Texas with a couple of my colleagues to measure emissions from abandoned wells in Texas. So So that's coming up. And then, we're looking at other regions, because something we're interested in is how do emission rates vary from different regions, right? So we'll take some samples in Texas. We've been to Kentucky. We've been to Oklahoma. We also have plans to go to New York. And something I didn't mention, which is interesting, is that the President Biden recently signed the bipartisan infrastructure bill, which is providing a lot of funding for us to do more research in this area. So this research program is just growing. I think there's a big interest in mitigating these abandoned wells. It can provide jobs for people. It can solve the greenhouse gas emissions problem and other hazards that they cause too. So we're real happy to see more interest on the subject and the funding that's going to be coming to us as well.
That's great. Okay, I see we do have a question. One of the questions we have is, do mineral right owners have to pay for plugging?
So I'm not real great on all the legal ins and outs, but generally I would say no. So if you're, well, it might depend on the history of ownership. Maybe I should put it that way. If a well is abandoned, meaning it hasn't been in production recently, and if you recall from the Pennsylvania definition, that's within the last 12 months, then there may be, depending on the date the well was drilled or the history of the ownership, there may be some responsibility there, but generally abandoned wells and certainly orphan wells they've become the responsibility of the state. And unfortunately, the state does not have enough resources financially or manpower to go out and plug every single abandoned well. So they have to prioritize. They choose the ones that pose the biggest risks and go after those first. So it's another thing that we'll be working on in the future is working with state agencies to figure out how they can attack this problem so that they're getting the most mitigation success for the resources that they have.
All right. Sorry, now I'm having technical difficulties here with trying to get my computer to behave.
Well, the chat. Let me see if there's any other questions in there.
If I was going to say, maybe you want to take a peek.
Why is it not working? Oh, there we go. Okay, I'm seeing a question about accepting volunteers to contribute pro bono skill sets and expertise, for example, supplemental to the GIS story map. Well, that's an interesting question, and certainly we like to interact with the general public in ways that sometimes we don't always predict. For instance, at Oil Creek State Park, and maybe some of you are aware of this, there's like a citizens group that they like to go out and record locations for abandoned wells and wells that they find when they're in the park. And so they shared that data with us, and we used that as part of our investigation. So certainly we accept, different avenues of collecting information. So for the person that asked that question, I would say, take a look at that story map, and if there's ways that you think you might want to contribute or thoughts to share about it, we're certainly happy to hear about that.
That's wonderful. Does anyone else have any questions for Natalie? If we don't get to it tonight, or if you're like me and you're just about to put your head on the pillow and you're like, oh, I should have asked her this, write it down or remember it. And you can send me an email in the morning, or if you copy down Natalie's email address, you can always email her. I will give my email address out. It is sargoodman@pa.gov. You can always drop me an email, and I will get that forwarded on to Natalie to answer your questions. But it doesn't look like we have any more questions at the moment. I am just fascinated as well, you think about these wells, just how many of them there were. Like, I know from working here and reading and studying and looking at maps that they really just, oh, we didn't hit anything here, we'll drill here, we'll drill here, we'll drill here. And it's so funny because I don't know why I really wasn't thinking that, okay, so yes, that might have been even an unsuccessful well and still could be emitting gases. Didn't really think about that, but it's it's an amazing thing to think. But I'm just fascinated with that LiDAR map. Was just so neat to see that rectangular, very distinctive rectangle and things like that. So absolutely amazing what technology can do today.
Yeah, you could still see that footprint 150 or so years later is really, yeah, it's amazing. And yeah, I mentioned limitations to that technique. So it wouldn't necessarily work in an area where if there was an oil boom somewhere and then, it ended and then somebody came in and strip mined. Right. Or maybe it turned into farmland that's plowed. Right. You can't see those features anymore, obviously. Right. So it will work on areas where there's, relatively little ground disturbance. Right. But yeah, the maps are really fascinating, and I think it's kind of a fun. It's been one of my favorite projects I've ever worked on. I just enjoy the almost scavenger hunt like part of it, where you've got these maps, we have these coordinates, now let's go out and see, we'll navigate to that spot and see if we can find a well. And that both with the magnetic and the LiDAR survey data, being able to do that is
and having others' photos. I mean, how lucky is that to have such great documentation with his photos? That's
really great. Yeah, I know those of us at NETL really enjoy kind of even just the historic aspect of working in this location, and the fact that there's the rich history, but there's also a lot more information in the photographs, in the materials at the Drake Well Museum. You don't have that at all the locations that we've visited. Certainly, like I mentioned earlier, we've been to Kentucky. We were in the Daniel Boone National Forest, so another, state or federal owned lands that are, available for us to go there and look around. We don't have the same photographic, record. So, right. We found it was a little harder for us finding wells there. We didn't do a magnetic survey either. We were mostly relying on digital database information. And so what I've shown here is almost like a best case example of a place where we have digital records. We did the magnetic survey, we did the LiDAR survey, we've got the photographs, we've got farm line maps, we've got a lot of different lines of evidence. So and the more lines of evidence that you have when you get out in the field, the better. So you're more prepared, you're more certain of where you think you're going to find a well, and that really cuts down on the time it takes to actually get out there and field verify.
That's wonderful. Yeah, that's great. Well, thank you, Natalie, so much for joining us this evening. It was great that we were finally able to have you, even though you couldn't be here in person. But you are welcome anytime to come back and present more findings, and even to discover findings about other oil regions would be a great talk to give, and maybe comparing and contrasting how Kentucky's compares to Pennsylvania's. It would be a really interesting talk. So you're not going to I'm not going to forget you. I might be contacting you down the road here to come back and talk again.
Absolutely. Same goes to anyone else here. If you want to, if this is for some reason a topic that really interests you and you want to keep in touch, just, shoot me an email, because with this funding that's coming in, we're going to continue this research for the next 5 years at least. And it's going to be, a program that's growing. So a lot more opportunities to further develop these techniques, to combine them with some other, cutting edge technologies. And so, we're really focused on cutting to the most efficient and most economical way to address this environmental issue.
Great. Thank you so much for joining us, Natalie. Thank you everyone else